Hey guys, welcome to lesson 15. In this lesson, we're going to talk about inverse functions. We've talked a lot about functions up to this point, but now we're going to take it in a different direction. All right, so when multiplying something, you can undo it by division. That is because those are inverse operations. If you have two functions that undo one another, then those are called inverse functions. All right, there are a few ways to tell if a function has an inverse. Okay, so a function is said to be one-to-one if each x value corresponds to one and only one y value, and the one y value corresponds to an x value. So in the beginning, we talked about how a relation is a function if none of the x's repeat, and we didn't care about the y's. Now we care about the y's. So if none of the x's repeat, it's a function. If none of the x's or y's repeat, it's one-to-one. And it has an inverse. Okay, so here's what we do. I want to know if f of a equals f of b. Okay, so that would be negative 4a plus 12 equals negative 4b plus 12. All right, so that's going to be subtract the 12, which you get negative 4a equals negative 4b, and you get divide the negative 4, you get a equals b. All right, so this is one way to show, hey, these are one-to-one. Okay, these are one-to-one. All right, another way to think about this is, okay, well, what times what, or 25 minus x squared. What squared is 25? Well, both 5 and negative 5. So we did a version of this on number 1, but now we're going to actually use real numbers. So if I do f of 5, that's going to be the square root of 25 minus the square root of 25 equals 0. F of negative 5 is square root of 25 minus square root of 25, which is 0. Because I was able to get the same answer from two different numbers, then they're not one-to-one. This is showing that my y's are going to repeat, which is a problem. All right, so they need to be distinct. The x's need to equal the y's. One x corresponds with one y. None of the x's don't repeat, the y's don't repeat. And because on this one, the y's repeated, this is not one-to-one. Okay, we look for a function using vertical line tests. We cannot use then a horizontal line test to see if it's one-to-one. So on number 3, all right, it fails the horizontal line test because it hits 2 points at the same time. So this is not one-to-one. On 4, it also fails the vertical line test. Or it passes the vertical line test, but it would fail the horizontal line test, so this is not one-to-one. All right, let's see, on 5, it passes the horizontal line test, so this is one-to-one. Okay. Now, two functions f and g are inverses if f of g of x equals x and g of f of x equals x. This says if you take the second function, plug it into the first function, get x, and then you turn around and take the first function, plug it into the second function, and also get x, those are one-to-one. But notice it says equals x. So if it equals anything else, you can stop because it's not going to work out at all. All right, so here's what we're talking about. So I want to find f of g of x. So that's going to be the cube root of x plus 1 times raised to the third power minus 1, and then I'm going to find out what it equals. All right, so the cubed gets rid of the root, and I'm left with x plus 1 minus 1, which is going to be x. All right, so far so good. I plugged g into f, I got x. So let's see. let's see what happens when I go the other direction and I take f and plug it into g. Okay, so that's going to be x cubed minus 1 parentheses cube root plus 1. Okay, so here I'm going to drop the parentheses. I got x cubed minus 1 plus 1, cube root of that. This is going to be the cube root of x cubed, which is just x. So I took the first function, I took the second function, plugged it into the first function, and I got x. And then I took the first function, plugged it into the second function, also got x. All right, so because they both equal x, f of x and g of x are inverses, and because they're inverses, we get a nice byproduct. Domain of f is the range of g and vice versa. Let's take a look at number 7. All right, so number 7, I'm going to try f of g of x. That's going to give me, let's see, 2 times 1/2 x minus 5 plus 5. All right, so that's going to give me half of 2 is x, or half of 2 is 1, so I get x minus 10 plus 5. So when I do that, I get x minus 5. Now, I can stop here because it says it's supposed to equal x, not anything else. This is x minus 5, not x. This must be x. Must be x. And since it's not, I know it's not going to be 1-to-1. I know these are not inverses, and so I can stop here. So, not inverses. All right. All right. So on 6 and 7, we were given 2 functions and showed whether or not they were inverses or not. But what if I'm just given one function? How can I find its inverse? Well, here are the rules for that. I'm going to replace f of x with y first, switch x and y, solve for y, and then replace it with proper notation. So let's actually put it in practice. So I'm going to change this to y. So I get y equals 2x plus 5. I'm going to switch x and y. So it says x equals 2y plus 5. And now I'm going to solve for y again. All right, so this can be x minus 5 equals 2y. X minus 5 over 2 equals y. And then I put it in proper notation. So I got f to the negative 1 of x equals x minus 5 over 2. That is going to be my inverse function to that. All right, let's keep going. All right, so we got, this is already in y, so I don't have to do anything. I'm just going to go ahead and switch the x's and y. So I got x equals y squared plus 2. All right, let's see. This can be x minus 2 equals y squared. You take the square root of both sides, so you get x minus 2 square root. And remember, when you take the square root, you got to consider the positive and the negative. So that equals y. And then I put it in proper notation. So I get f to the negative 1 of x equals plus or minus the square root of x minus 2. All right? So x squared plus 2 is a parabola. It would pass the horizontal line test. So this checks out. All right, x minus 2 is a cubic graph. This will also pass the horizontal line test, so it will have an inverse. So let's try this. Switch that to y. X minus 2 cubed. X equals y minus 2 cubed. Take the cube root of both sides, and because it's an odd root, I don't have to consider positive and negative, so I can just take cube root of x equals y minus 2. Cube root of x plus 2 equals y. Put it in the right notation, f to the negative 1 x equals, so this would equal cube root of x plus 2. All right, so there's that. Let's go back to 9 for a second. I told you this is a parabola. At plus 2, it sits above it. This would fail the horizontal line test. So because it fails the horizontal line test, this would not have an inverse. It's not 1-to-1. So I can actually get rid of all this and say it's not 1-to-1. And because it fails the horizontal line test. Okay, so now 10, similarly, right, this would be that graph, which would also fail the horizontal line test. And because of that, this is not 1-to-1 because it fails the horizontal line test. All right. Number 12. This one is this graph should have a inverse. It should pass the horizontal line test. So y equals 2x plus 3 over x minus 4. All right, switch x and y, so you get 2y plus 3 over y minus 4. Okay, I need to get the denominator out of I need to get rid of the fraction, so I'm going to multiply both sides by y minus 4. So that's going to be x times y minus 4 equals 2y plus 3. Distribute the x to get xy minus 4x equals 2y plus 3. Get all the y's on the same side. All right, so it's going to be xy minus 2y minus 4x equals 3. Xy minus 2y equals 4x plus 3. Take out the y, so you got y times x minus 2, 4x plus 3. Divide by everything that's not y, so you get y equals 4x plus 3 over x minus 2. Put it in proper notation. My inverse is going to be 4x plus 3 over x minus 2. All right? So if I say x minus 2 equals 0, I get x equals 2. So my domain for this is going to be x does not equal 2. All right? So it's something we had to consider because of the fraction part of it, but that's that. All right, guys. That is lesson 15. Hope you got something out of it. If you have any questions, reach out, and I'll see you in the next lesson.